Ever wondered how a computer actually works? That slim slab of metal and silicon sitting on your desk is performing billions of calculations per second. But what's really going on under the hood? Let's break it down. At the heart of every computer is the CPU, or central processing unit, often called the brain of the machine. It fetches instructions from memory, decodes them, then executes them, all in mere nanoseconds. Each instruction is made of binary code, strings of ones and zeros that tell the CPU exactly what to do, whether it's adding numbers, moving data, or comparing values. Supporting the CPU is RAM, short for Random Access Memory. This is your system's short-term memory, where active data and programs are temporarily stored for lightning-fast access. RAM allows your system to multitask, like keeping a browser, a game, and a spreadsheet open at the same time without grinding to a halt. Permanent data like your files, photos, and software lives on the storage drive, typically an SSD or HDD. SSDs are faster because they use flash memory, no moving parts, while HDDs rely on spinning magnetic disks. But none of this would work without the motherboard, a complex circuit board that connects everything together. The CPU, RAM, storage, GPU, power supply, and ports. It's the nervous system of your computer, allowing signals and data to travel across its copper traces in the form of electrical pulses. Then there's the GPU, or Graphics Processing Unit, a specialized chip designed to handle image rendering and massive parallel calculations, crucial for gaming, video editing, 3D modeling, and increasingly, artificial intelligence. Every action you take, pressing a key, clicking a mouse, triggers a cascade of signals. Input devices send these electrical signals into the system, where the operating system, like Windows, Mac OS, or Linux, interprets them. The OS is essentially the master translator. It sits between you and the hardware, managing files, memory, processes, and device drivers, which are tiny programs that let hardware like printers or webcams communicate with the system. So how can a computer do all the tasks we take for granted, like browsing the internet or writing code? It all comes down to software. Applications like web browsers, code editors, and media players are built using programming languages, sets of instructions that get compiled into binary the machine understands. When you open a browser, the CPU processes the code behind it, connects through your network card to the internet using standardized protocols like HTTP, and requests web pages from servers all over the world. To response, HTML, CSS, JavaScript gets processed, laid out, and rendered by the browser using both the CPU and GPU. When you write code, you're actually creating new instructions that, once compiled or interpreted, can command the computer to perform entirely new tasks. This modularity is what makes computers so powerful. By simply installing different software, you can turn the same hardware into a music studio, a gaming console, or a development environment. Want to play a video? Your OS hands the file off to a media player, which decodes the compressed data using a codec, streams it into RAM, and renders it on your display frame by frame using the GPU, all in real time. Want to talk to a friend? Your mic captures analog audio, converts it into digital data via an ADC, analog to digital converter, sends it through your network adapter, and transmits it over the web using VoIP protocols. Everything works because computers follow strict, logical rules encoded in hardware and software, governed by millions, even billions of tiny transistors, which act as on-off switches to create logic gates. These gates form the backbone of all digital operations, from simple calculations to complex AI models. Behind every YouTube video you watch or document you type is a choreographed dance of electrons, memory fetches, bus transfers, and logic circuits working in perfect sync. It's not magic, it's engineering. So next time you boot up your laptop, remember, it's not just a box, it's a symphony of silicon, software, and science that's reshaping the world as we know it. And if you enjoyed learning how your computer really works, don't forget to hit that subscribe button, because here at Knowledge Hub, we make tech make sense, and as always, stay curious.